Okay, this is our second example doing mesh analysis, and again we start by assigning currents to each one of the meshes. After we assign the currents, then we start checking for the polarities. So this is plus minus. Remember, we have plus in the terminal where the current enters and negative where the current exits, according to the direction that we assign. And remember, you assign, okay, you decide what direction, and later when you solve the problem, you will know by the sign of the solution if your assignment was right or wrong. Okay, but sorry. sorry, this is, I don't need to assign here. What I need to assign is here. Sorry, it's only in the resistors. Okay, the other. So now I'm gonna start doing mesh 1. Now I'm gonna apply to mesh 1 Kirchhoff voltage law, and remember, we are gonna imagine that I start here and that I'm gonna walk the entire mesh. So the first thing that I see is that resistor. So we have 3 times what? I1 minus I2. Why? Because in this branch, okay, we have one mesh where the current is flowing in this direction as I1, and then a current flowing in this direction that is I2. That's why this is what I have. I continue and I see another plus, so now I have 10, but this is only times I1, because I1 is the only current flowing in this branch, because this branch is not shared with any other mesh. When I cross the resistor and I continue walking, I get here, and then I have another plus 2, but this one is going to be what? I1 minus I3 equals 0, and when I cross the resistor, I am back to my original point. That's why this is equal to 0. Now, there is going to be a problem with mesh 2 and mesh 3. Why? Because if you start walking, okay, you start walking all the elements, and the same is going to happen with the other one, okay? If you start walking all the elements, at some point you're going to reach this 5 ampere current source. And remember that because this is Kirchhoff voltage law, all of these are voltages, okay? If you see the units, these are voltages. So the problem is that when we get to this point, the question is, what is the voltage across a 5 ampere current source? And we don't know. You cannot say that 5 amperes is equal to 5 volts. Actually, we can have a voltage of 0 here. We can have a voltage of 1 million. We don't know, okay? We can have a negative voltage. You know, there is no way, and we don't have something equivalent to Ohm's law. Okay, so there is no law there that tells us what voltage, okay, goes here. So this is a problem. So we cannot do Kirchhoff voltage law for mesh 2 or for mesh 3. So then we need to come with another trick. And the trick is the following. The trick is that Kirchhoff voltage law works not just for a mesh, but for any loop, okay? For any closed loop, okay, it's gonna work. So instead of walking the meshes, what we're gonna do is walk in this way. Look, I'm using the brown, follow the brown, okay? So I'm gonna go and walk the loop. So I'm gonna start here, okay, walking through the perimeter of this loop, and I'm gonna be back here, but without going through this path, okay? I'm basically avoiding the path of the 5 ampere current source. So at this, okay, this big loop is basically a combination of mesh 2 and mesh 3. So I'm gonna call this super mesh, okay? And it's a combination of mesh 2 and mesh 3. So if I apply, if I start my walk here, okay, the first thing that you're gonna see, the positive and the negative go here. Okay, this is positive, this is negative. So I have 6 times I2. Then here I have negative minus 100 volts because I am entering into the negative terminal. If I continue, I see another plus, so I have a 3 times what? I2 minus I1, because that is the current in this branch. I continue walking and I get to this point, so I have another plus, okay, and the current there is I3 minus I1, okay. I continue and I get to this plus 50, okay. When I cross this, basically I am back to the origin, so this is equal to 0. So I want you to notice that this is equation 1, this is equation 2, but I have 3 unknowns. So I need one extra equation. From where do I get that equation? Please notice that it is impossible to do more mesh analysis. Basically, we are done. So what we're going to do now is I want you to notice that in this branch, okay, here in brown, the current flowing there is determined by this current source. So we know that in this branch we have 5 amperes. But on the other hand, these 5 amperes, okay, are also related to this current and to this current in this way. I3 minus I2 is equal to 5. Why? Look. So we know that we have 5 amperes going here. Well, from this side, from this mesh, we have I3 going up, but from this side we have I2 going down. So that's why, and because 5 is going up, that's why this is the one that is positive. So I3 minus I2 is equal to 5, and this is the third equation. So this is a concept of super mesh, okay? And you're gonna use this concept every time that in the branch, okay, you have a current source. And the reason is because you don't know what is the voltage there. That's why you cannot just say minus 5 volts, because 5 amperes is completely different to 5 volts. So now we have the 3 equations with 3 unknowns. If you go to your preferred method to solve this, you're gonna find that I2 is gonna be equal to 1.75 amperes. I1, I'm giving you already the solutions, okay? You can try this at home if you want. And I3 is gonna be 1. Sorry, I made here a mistake. This is 6.75 amperes. That is I3. And this is our second example using mesh analysis.